Okay. Morning, everybody. Recording this before work today. Hopefully, this is helpful, um, especially where a lot of you all are going to be out in second period. I thought this would be a really good way to allow you all to kind of stay on pace because um, the expectation is for everybody to have all this work done by the time we come back tomorrow. So I just wanted to take a moment and explain a couple things. So one thing I noticed on this formative we took yesterday was that we struggled with the composition, proving proving that functions are inverses. Okay, so what this means is this rule. The functions are inverses if and only if, which means it has to be this way. There's like if this doesn't work, then they can't possibly be inverses. So functions are inverses if and only if composition both ways yields x. So let me show a quick example. So say I have f of x equals 2x minus or plus 8, sorry. Then g of x 1/2 x minus 4. Okay, so basically what I'm checking for here is I'm going to try plugging g into f, and then I'm going to try plugging f into g. And really, like what I'm looking for here is this. Do I get x this way? So let me zoom in just a little bit. So we talked about the steps here. First one, write my first function. Then just plug it in where x is and distribute. So that gives me x minus 8 plus 8. These cancel out, and I'm left with x. Boom, that one's good. And then here, I'm looking at writing the first one, replacing it here, 2x plus 8 minus 4, distribute again. That gives me x plus 4 minus 4. And notice, usually once you get to the step where you're distributing, especially with linear, you end up just canceling out with x. Okay, so that's proven that functions are inverses. If you still have questions about this, make sure to email me and I can send you more resources that are helpful because we're going to be taking our test pretty soon. Okay, now let's go to the second thing. So inverses of quadratics. I'm just going to show a couple of examples because the steps are the exact same as linear inverses, right? And I'll talk through them as I do them. So let's see here. Let's just start in step one. Or like example one. So say I have f of x equals Who knows? 2x squared. Actually, yeah. Let's just keep it simple at first. So, first step, rewrite as y. You all know these steps by heart now. Flipping the variable. And now, same thing here. I'm trying to get y by itself. Divide the 2. So that gives me 1/2 x equals y squared. So now, when I take the square root on both sides, because that's my next step on taking and getting y by itself, I end up with square root of 1/2 x equals y. And then just flipping it back around and writing it like you used to, you get that the inverse of f of x is the square root of 1/2 x. Okay? So let me show you a little bit more complicated of an example. Just showing you multiple. If you feel like you get this pretty good, you can go ahead and skip this. But I'm just wanting to offer up tons of examples here. So let's do a weird one. So let's look at this. First steps are always the same. Just rewriting the variables. Okay, now, once again, you're just doing algebra, right? I have to multiply on both sides by 4 to get the y by itself. So 4x equals y plus 3 squared. Obviously, I do need to get rid of the 3, but like I kind of think of it like PEMDAS in reverse, right? I've got to take care of the exponents before I can. So, taking the square root on both sides. And I don't think I would take off on a test for this, but if the number in front of x here, so let me highlight this for you. So if this number right here can be simplified, like the square root of 4, it's 2, right? So the 2, then square root of x doesn't simplify. That's how technically you should write it. Okay? Now, from here, you just subtract this over. This can't combine, so you got this 2 square root of x minus 3 equals y. Okay. Couple more the other way. So let's say I give you a square root first instead. Okay, so let's solve it. So y equals square root of 3x. Switch them. Now, here's the thing though. In this case, I've got the square root already, right? It's kind of like multiply and divide. Like one of them undoes the other. So, like right here, for example, what I did is I had to take the square root to undo squared. But now to undo the square root, it's just opposite. I square both sides. So x squared just gives me x squared, then 3y, then one last step, divide by 3, so I get 1/3 x squared equals y. And then, obviously, rewriting it. Boom. Okay. One more. Let's take it up a notch a little bit. Let's see. So here I've got the square root of x over 4 minus 5. So the minus 5 right here is outside of the square root. So don't even need to say anything for these two steps. Okay, just switching them. Now, here's the weird thing, right? So I add 5 on both sides. Okay, pretty simple. But now that I've got the square root by itself to where I can take care of it, I do the same steps, right? I square it on both sides. But notice, you have to square the entirety of both sides. So right here, got x plus 5 squared. And remember, squared means anything times itself, which you know, but this is saying x plus 5 times x plus 5 equals, these cancel out, y over 4. So when I'm doing this right here, I need to, whatever method that you usually use, I use the box method for this. I've got my little box here, both sides, x plus 5, x plus 5, and just multiplying that, x squared, 5x, 5x, and 25. And this gives me x squared plus 10x plus 25. So squaring that gives me that. And my final step is multiplying by 4, right? I gotta get the 4 off the bottom. Now, think of this though. I need to get rid of this. And now I'm multiplying 4 on both sides, and it's all of both sides. So remember, anytime you multiply to whatever you do to one side, you have to do the entirety of the other side. So this is going to multiply that 4 by all of them. So what this gives you is that your inverse here, 4x squared plus 40x plus 100 is y. So your inverse actually is going to be 4x squared plus 40x plus 100. Okay? So, if we have any other questions other than that, just make sure to email me and I'll do my best to answer those, or just come see me in class today. And if you're watching this in class, just go ahead and move on to the next thing on the agenda. And for everybody, regardless of whether you're in class or not, make sure you watch this, get this done, and get done all the stuff in the 1019 agenda. Have a good day.